Okay, we are going to keep going with our integration by parts quest here. I'm going to do 2 more examples of an integration by parts, okay? So here is another example. So I have the integral of x cos 3x dx. So before we look at a question, we always have to think about, how am I going to know this is a substitution question? Well, when you have 2 functions, the first thing you can check is the derivative of the inside here. And it's not. We have an extra x because the derivative of 3x is 3, so I have an extra x. So I know I can't use substitution. So I know I need to use integration by parts. So the next thing I need to figure out is what's my u and what's my dv, okay? So u you need to find the derivative of, and dv you need to find the integral of. Sometimes it matters and sometimes it doesn't, which one you choose. So let's just go ahead and pick. So I'm going to make ux and I'm going to make dv cos 3x dx. And remember that whatever you pick for dv, the dx goes with it. So now I'm going to keep going. So I need to find the derivative of u. So du dx is 1. So du is dx. And I need to find the integral of v. So the integral of cos 3x is going to be, well, basically you're looking at it as if that was the derivative. So it's going to be minus sine, positive sine, 3x, times a third. Now I can just kind of stare that one down. It's obvious to me that the integral of cos 3x is sine 3x, right? Because the derivative of sine is cos. But whenever you're finding the derivative of a trig function, you multiply by the derivative of the angle. So the derivative of the angle is 3, but I didn't have a 3 in front of here, so I compensated by multiplying by a third. I hope that makes sense. Okay, so now we're going to go ahead and plug it in this formula. Okay, so I have, this is my u, this is my dv. So I'm going to plug it in here. So my formula tells me to do u times v minus the integral of v. I'm going to bring the third on the outside, du. Okay, so then I just filled it all in my formula. So now I go ahead and clean this part up and find the integral of this guy. So this is just x over 3 sine 3x minus, what's the integral of sine of 3x? So the integral of sine of 3x is negative cos 3x times a third. So I'm going to have a 9th cos 3x plus c. So that is how we do integration by parts with that particular question. All right, so now I'm going to do one that you probably might start off doing incorrectly. So integration by parts question, I have 2 unique functions, so I need to figure out which piece I want to be u and which piece I want to be dv. Now, before, by chance, this was u, this is the dv. I can't just assume that. And for me, some of them are obvious and some of them aren't. So when it's not obvious, I just try something. So if we start this, let's make u x squared, and dv is the natural log of x dx. So the derivative of u, du dx, is 2x, no problems there. So du is 2x dx. Here I need to do v. What is the integral of the natural log of x? I don't know the integral of the natural log of x. So this is not a good idea. Danger. So I'm going to switch it. I'm going to make u the natural log of x, and I'm going to make dv x squared dx. And I'm going to try it. So du dx is 1 over x. So du is 1 over x dx. V, so I'm finding the integral of v is x cubed over 3 plus c, but I don't put that part in until I get to the end. So things are looking better now. I'm going to plug it in here. So my formula tells me to do u times v minus the integral of v du. So I'm going to do some cleaning up here. So I'm going to just write this as x cubed natural log of x all over 3 minus, I'm going to bring the third on the outside. Now I have x cubed times 1 over x, so that's x squared dx. And then I'm just going to find the integral of x squared dx. So that's x3 over 3. We'll just make that a 9 plus c. That's how I do integration by parts.